Hello again, everybody, and welcome back. I hope that you're all doing well. We are going to continue on with our studies of rocks and minerals, and last time we talked about the rock cycle. So let's jump into our first rock, which are igneous rocks. So we're going to look at them and characterize them by certain characteristics that they do have and how they form and what they're made of, and really jump into the Earth Science Reference Table chart about how to read that particular chart. So let's get started. Okay. So in your reference tables on page 6, which is right near that rock cycle diagram, we have a chart that looks just like this, and it says scheme for igneous rock identification. And basically, it is just going to help you use the characteristics to figure out what igneous rock is right near you. So it's kind of similar to the chart that we were talking about with minerals, except now we're focusing more on rocks, and the setup is a little bit differently. But the idea is if you use the characteristics of igneous rocks, you should be able to identify which rock it is. Okay, so we're going to look at these guys right here. So if you have a red pencil or highlighter, I would definitely recommend having something with you because we're going to be kind of marking up this chart in your notes so you know how to read it. These are the rocks that we're going to be talking about. These are the common ones that we'll talk about in this class. Obviously, there are more, but we're going to focus on these guys. So those are the rocks themselves, and the pieces around you can see are just going to be some of the characteristics. Okay, so let's just talk about how an igneous rock forms in general. Now, if you go back and you look at your Earth Science reference tables and you see that chart with the rock cycle chart, you will see how it forms, but let's just give it an actual kind of name here. So again, on your reference tables, you have magma, solidification, igneous rocks. Now, in order to get to this point, you have to melt a rock. But we're going to start off at the point where you really get to be an igneous rock, or you're on your way to being an igneous rock, and that's definitely through magma. But all the rocks will be melted to that point. So very quickly, let's talk about the difference between magma and lava. Okay, so igneous rocks will form with magma, melted rock that's below, or lava, which is melted rock that occurs above Earth's surface. Now, the important thing here to remember is that you are getting something to cool and solidify. So you're taking that rock, whether it's made from magma or lava. So yes, if you go back here, I know it says magma, but you can also have lava as well. Okay, and we're going to cool it and we're going to solidify it. And when we talked about that, when we talked about the reference table chart with the rock cycles, we said solidifies just means to become a solid. So you're taking liquid rock and you're now making it a solid rock by cooling it down. But you can use either magma or lava to do this. So the process can happen with either one. So just really big difference here again to kind of drive the point home is that you want to really know the difference between magma and lava and where it forms, because that's definitely going to come into play. How will it do that? Glad you asked. Okay, if you look up here at the top of your Earth Science reference tables chart for igneous rocks, you'll see a side that says intrusive versus extrusive. So in that green area on the top, it's got that little point on the side, and I'll just kind of circle it for you guys so you can see it. Right over here. It says extrusive, and that says volcanic, and intrusive, which says plutonic. And basically what you want to realize here is that extrusive means on Earth's surface, and intrusive means below Earth's surface. I like to think of it this way. If I look at the word like extrusive, it looks like exit. And I like to think about it as exiting the interior of Earth and going on Earth's surface. And you can also look at the in and intrusive, and you can think of it as in Earth's surface, or inside Earth's surface is where it's going to be formed. So if you look at this chart here, you can see that anything that is highlighted in green is going to be a rock that formed on Earth's surface, or the extrusive rock, and anything that's highlighted in yellow is going to be the extrusive, or formed below Earth's surface. Okay, and they have certain characteristics to them, whether they formed on or off Earth's surface. And you'll kind of see that over here in that crystal green size, and you'll see it over here with texture. Okay, texture more specifically for that vesicular texture, which we'll talk about in a second. But you can see certain characteristics that we're going to dive into in a second that really go with if you form below or above Earth's surface, extrusive or intrusive. So let's just break those two down. So if you have something that, there we go, if you have an extrusive rock, we're on number 2 in your notes. We're talking about the difference between extrusive and intrusive. If you have an extrusive rock, you have these following characteristics. So something that forms outside Earth's surface, on top of Earth's surface, not inside Earth's surface. Okay, these things are going to be volcanic, and what that means is that they're going to cool on Earth's surface, as we just said. So things that might have come out of a volcano, for instance, okay, they're going to cool faster. And this is super important to kind of recognize, because the cooling rate is going to affect certain things. I'm going to highlight that, or certain characteristics that the rock has. Okay, specifically, it's going to be very fine-grained or glassy or vesicular. Now, we're going to come back to vesicular in a second, but vesicular just means little holes in it made from gas pockets. We call them gas pockets. So you'll see kind of like little holes in them. They have a very specific texture and feel to them. And then fine-grained versus glassy, something that's fine-grained, they're going to be made of smaller things versus glassy. Obviously, you guys would know what glass is at this point, hopefully. Okay. And just to define what vesicular means, it's vesicular meaning having gas pockets or holes if the gas bubbles will trap in the rapidly cooling lava. And again, the point here we want to drive home is that the extrusive rocks are going to cool a lot faster. So when it cools, a lot of the things in the rock don't have a ton of time to develop, such as the crystals or the grain size, which we'll talk about a little bit in a second. So by it cooling faster basically means that you're going to have smaller things, or it's going to look glassy. You're going to get these gas pockets that are trapped in there because the process is happening rather quickly. Okay. On the other side, we have intrusive rocks. Now, these are the things that are inside. Just maybe I can write that down for you guys. So we'll say, oh, no, you can see it. Okay, intrusive is almost quite literally the opposite of extrusive. So now you have things that are cooling slowly beneath Earth's surface. So when things cool down slowly, they have time to kind of develop, and you get different characteristics, such as its texture. Something that is coarse or very coarse, I don't know if you can think of sandpaper, very coarse, very rough sandpaper versus something that's fine grained, where it's a little bit smoother grained, not as rough. Okay. They definitely have larger crystal sizes, again, because it just took longer to form. So this is just a slow process. So they had time to develop these crystal sizes. Okay, whoop. Yes, we're good. Okay, so the texture, again, is coarse in an intrusive rock, fine in an extrusive rock. They're going to have a lot more of a bigger crystal size because the rock took longer to form. So we're going to investigate that a little bit more here. Okay, now if I go back to the earth science reference tables, and again, I take a look at the intrusive rocks, and you go over to crystal size. Let me just get my red marker here so you guys can see what I'm talking about, right? You have the crystal size and you have the texture over here. Now, the crystal size for an extrusive rock, they're telling you non-crystalline, which just basically means you're not going to see any crystal sizes in it, and that's a characteristic for like scoria or scorcha, scoria, I don't know how you want to pronounce it, pumice, obsidian, and basaltic glass. So these guys they don't really have that crystal structure. So they're going to look a little glassy, or they're going to be very fine. Okay, there's no real like crystals in them. You don't really see it that often, right? So they're very, very fine. In fact, anybody that gets their feet done at the nail salons, when you do that, they kind of rub the bottom of your feet. They do that with pumice, or that's what mine uses. Could change depending on where you are. Okay, and the texture over here, you see glassy and you see fine. So something that is a glassy texture looks something like glass. I'll show you a visual about it in a second. And then you have fine, which is just those types of rocks that have that very fine texture to them, not as rough as you would see something with coarse. Okay, okay, that's the ones that formed on Earth's surface. Now, if we jump down here and we look at the extrusive, which is the ones that don't form on Earth's surface, these are the things that are below Earth's surface, you're going to notice that their crystal size and their texture are much different. So you can have something that has a texture or a crystal size of 1 millimeter to 10 millimeters, or you can have something that's larger. Okay. And then their texture are going to be very coarse or just coarse compared to something that was formed on Earth's surface. Okay, so if any of you have a granite countertop, or know somebody that has a granite countertop, you can kind of see the crystal sizes, and you can see those little different colors. You can see a lot of the different colors that's made up of granite. That's what we're talking about by coarse grained or crystal size. You can definitely see the different patterns and the different colors in granite because it had a longer time to cool, and those crystals were able to grow, make themselves much more noticeable. Okay. Moving on from there, let's just talk about what these igneous rocks are made. Oh, nope, sorry, we jumped ahead a little bit. Well, let me give you some examples of an extrusive igneous rock. So I'm going to show you pictures over here. You have two rocks. I believe the one on the left is pumice. Okay, that's a fine grain texture. You don't really see a lot of crystals in there. Everything kind of looks uniform. If you were to touch it, you would feel how fine grain it was. And then on the right, you have obsidian. Obsidian, that's the difference of your glassy texture. It looks very smooth, almost glass-like, so you can see that. And then the intrusive rocks, there's granite. There it is. So when you think of coarse or very coarse, you really want to think of granite. You can see the different colors. You can see the different crystals. It had a longer time to cool. Therefore, you can see those kind of different things that make up granite. Versus if you guys were over here, you don't really see a lot of the different things that made it up. You can get kind of ideas in pumice, but they're not as defined as granite would be. Okay, so definitely think of granite when you think of an intrusive rock. It's probably the best example, one of the best examples. Okay, moving on. What are igneous rocks made of? Now, this is fun because they're cooling differently and in different places, so they get different characteristics. And this is what one of them is what they're made up of. And you can have two different types. You can have felsic. Now, a felsic composition basically means it's rich in aluminum, Al, and silicon. Now, remember we talked about those elements when we were talking about minerals, right? So felsic rocks have these types of elements in them, aluminum and silicon. And they're lighter in color and lower in density. So these will be your light, less dense rocks, basically. On the opposite side, you have mafic. I love mafic. I just like saying the word mafic. Okay, mafic rocks are rich in iron and magnesium, and they are typically darker in color and higher in density. So again, just a flip-flop on there, and this is part of their composition, what they're made of. And you'll see in a second how we can use the reference tables to kind of figure this out. Give you guys a second to just write that down while I take a sip of water. All right. Okay, let's jump to the reference tables. Now, on the bottom, just underneath where all the rocks are named, you're going to see this little bar that says characteristics, and you have color, you have density, and you have composition. So this is kind of like what we're talking about over here. Okay, let's take a look at the felsic rocks. Now, the felsic rocks are over here, and you'll see that it's composition. Now, if you look right underneath here, let me just kind of highlight it. Oop. Right, if you highlight it right here, you can see, oh no, it's not working. Of course it's not working. Why would it not? There it is. And it tells you it's rich in silicon and aluminum. So you don't have to worry about remembering what they're made of. You can see it there. Okay, its color, you're going to just literally follow the line. You'll see that it's lighter in color. And its density, literally, they tell you everything that you need to know right on this chart. You don't have to really remember much of it. You just have to know how to read the chart, is lower density. Okay, now the things that mafic rocks generally are made up of, again, you're going to have different amounts. You're going to have these types of minerals that are going to make up these types of felsic rocks. So if you look right here, okay, you're going to see that on the felsic side, you have this, let me just highlight a little piece here. You have this dotted line. Oh, sorry guys, my iPad is just being non-cooperative. You have this little dotted line here, right? And it, again, everything kind of lines up with the entire chart. So if you were to continue this up, you can kind of see how it kind of chunks everything together. We're just going to focus on down here, right? You have these minerals. You have potassium feldspar, you have quartz, biotites in there as well, because you can kind of see the patterns. And dependent on how much of those minerals that you have that make up the particular rock, you'll have different percentages. So you'll might have more quartz than you do biotite. You might have more feldspar than you do amphibole, but that's pretty much how those rocks are made up. But what I really want to point out to you guys is that those types of rocks, if you look at, like, for example, quartz, and you look at potassium feldspar, you'll see that their colors are actually very light as well, pink to white, clear to white. So that's probably where the lighter color is coming from, right? Lower density, that's what those rocks, lower density, again, if you look at the density, if something's less dense or more dense, I think you guys actually know that pretty well. And then the felsic is just telling you where it's rich in composition. But just want to make sure you guys understand that the bottom part is that mineral composition, and it does affect the color, the density, and obviously if it's felsic or mafic. So if we go on the other side here and we look at the mafic side, so we're going to just do this. They're over here. Okay, you do the same exact thing. You have darker higher density. It's telling you it's mafic, and those are the minerals, I'm sorry, the elements that it's made up of. And just as we did before with the the felsic, you can see, okay, there's the density, there's the color, okay, and there's the composition. And I just realized I switched color and density, but it doesn't matter because it's all there, okay? And if you look at the types of minerals that make up mafic rocks for the majority, you can see that majority of them will probably have some sort of green. You can have black and amphibole, that's over there. So some of those minerals do kind of go, they're in both, right? They're both in mafic and felsic. But again, it has to do with how much and the composition of what minerals they're made of that will tell you if it's mafic or if it is felsic. Okay? So I just want to kind of point that out to you guys. So take a look at that a little bit. Knowing how to read this chart is very, very, very important. Okay? So if I had to boil it down, and you said to me, Miss F, what are the things, what are the key features that I need to know about igneous rocks? Here it is. When you're looking for an igneous rock, you want to look for three things. The first thing you want to look for is if it's got a good glassy texture. If it's got a glassy texture, you're going to think obsidian. You know, and we introduced obsidian before. And once you identify the rock, you can find that easily on your reference tables, and you can give you any characteristic that you're looking for, okay? You also want to look for interlocking or intergrown crystals. This is big because it comes out on the regions when we actually talk about the stations, the lab stations. This is one of the things that you're going to have to remember. So if you see interlocking grown crystals, especially with granite, that's a good one to kind of figure out. You'll know that it is an igneous rock. Granite's a dead giveaway on that one. Okay, and last but not least, you want to look for gas pockets. Vesicular gas pockets, that just basically means the rock cooled very quickly, really, really fast, and those gas pockets or those gas bubbles didn't have time to escape, so kind of made a bubble into the rock, and that's another defining characteristic of igneous rocks. Okay, so we have reached the end of our discussion about igneous rocks. You have a couple of questions to answer about igneous rocks in your notes. So take some time, do that. Definitely look over your reference table when you get the chance to, and really come to know that rock chart for igneous rocks. It's going to be very, very helpful in a lot of your identifications of rocks, especially igneous rocks, because that's what we're talking about. So you'll kind of see that those rocks for all three, igneous, sedimentary, metamorphic, those charts are very, very helpful. So this is where I leave you. Continue to work on for the igneous rocks, and then I will see you again on the next video. Take care, guys.